Hey everyone, so we're diving into a really massive problem in AI today. How do you get an AI to understand an entire book or, a super complex legal file all at once? Well, a new solution called Glyph has this absolutely brilliant answer. It's basically teaching the AI to stop reading words and start seeing them as pictures. It's wild. So let's start with a really simple question. Why can't you just, hand an AI like ChatGPT a whole novel and ask about the entire plot? Why does it get so bogged down with really, really long documents? I mean, it seems like such a basic thing to ask, but it turns out it's one of the single biggest challenges in AI right now. The answer, it turns out, is something called the context window. The best way to think about it is like an AI's short-term memory. It's this box of a very specific size, and you can only fit so many words, or what we call tokens, inside it at one time. So take a standard AI with, say, 128,000 token window. It just can't fit the entire novel Jane Eyre inside that box. The book's about 240,000 tokens. You literally can't ask a question about the ending because by the time the AI gets there, it's already forgotten the beginning. And just making that box bigger, well, that's incredibly expensive and just a nightmare for computers to handle. It's a huge bottleneck. All right, so here's our plan. First, we'll dig into this million token problem. Then we'll see Glyph's super clever pivot to using images. After that, we'll cover how it's trained. We're calling it an AI eye exam. Then we'll check the results, Glyph's report card. And finally, we'll look at what this all means for the future of AI. Okay, let's dive into that core challenge. The big dream for so many developers is to create AIs that can handle 1 million tokens, or even more. But like we just said, the old school way of doing this, just, making that context window bigger and bigger, is hitting a really serious wall. And yeah, this really shows the problem perfectly. It's not just about throwing more computer chips at it. The complexity just explodes. The current method is kind of like trying to build a skyscraper out of wood. I mean, eventually, the whole thing just collapses under its own weight. We need a totally new building material. And this is where the pure genius of Glyph comes in. The researchers basically asked a totally different question. They said, okay, what if, instead of feeding the AI this long, boring stream of text tokens, what if we turned all that text into a picture and just had a vision AI look at it? This quote from the research paper really nails the core idea. It's about rendering plain text into images, basically drawing the text. And then they use a different kind of AI called a vision language model, or VLM, which is built from the ground up to understand both pictures and words. This lets it compress all that information into a much, much denser format. Just look at the difference here. On the left, you've got the old way, this massive, super long sequence of individual text tokens. It's just inefficient. But on the right, that's the Glyph approach. That entire block of text becomes one compact image. And the AI processes that picture using what are called visual tokens, which are way more packed with information. So what's the actual payoff? A massive 3 to 4 times compression rate. That means the AI is processing 3 to 4 times less data to understand the exact same amount of text. And let's be super clear, this isn't about losing information. It's about packing it in a much, much smarter and more efficient way. Okay, let's circle back to our Jane Eyre example. Remember that 240,000 token novel that just wouldn't fit? Well, Glyph turns it into a set of images that total only about 80,000 visual tokens. And just like that, poof, the entire book fits, with room to spare. The AI can finally see the whole story, from beginning to end, all at once. Now, this all sounds fantastic in theory, right? But how do you actually teach an AI to read text this way? It's definitely not simple. The process needs a really sophisticated training setup, which, honestly, the researchers designed brilliantly. We're calling it the AI eye exam. So the whole framework has 3 main stages. Step 1 is continual pre-training, which is just teaching the AI to read text in a ton of different visual styles. Step 2 is that LLM-driven rendering search. That's the eye exam we were talking about. And finally, step 3 is post-training, where the model gets fine-tuned to be a real expert. Let's zoom in on that second step, because this is where it gets really clever. The eye exam is basically a process where another AI acts like an optometrist. Its only job is to figure out the absolute best way to show the text to the main AI. Like, is it cleared with a bigger font? Or this one? Tighter line spacing? Dark mode? It runs this thing called a genetic search algorithm, which is perfect for this. It can just rapidly test thousands and thousands of combinations, and it lets the best ones survive and combine until it evolves the perfect font prescription. And this gives you an idea of what that prescription actually looks like. The AI is tweaking all these different settings, things like DPI, page size, font style, even the colors. It's just hunting for that perfect combination that gives it the best balance of high compression and, actually reading the words correctly. The whole goal is to make the text as dense as possible without the AI messing up and misreading it. Okay, so the theory is elegant. The training process is super smart, but does it actually work? Time to look at the data. Let's check out Glyph's report card and see how it stacks up against the regular text-only models. And the results are, well, they're pretty impressive. On Longbench, which is a really important test for this kind of long document understanding, Glyph actually scores higher than a leading text-only model of a similar size. The big takeaway here is that it massively compresses the text without losing any accuracy. In fact, it actually does better. That's huge. Oh, and it gets even better. Because the model is processing so much less data, it's also way, way faster. We're talking nearly 5 times faster at that initial read of a document, what's called pre-filling, and over 4 times faster at generating a response or decoding. That is a massive leap in efficiency. And this efficiency carries over into the training process itself. Fine-tuning the Glyph model is about twice as fast as training a normal text-only version. And that's a big deal because it makes developing and improving these really powerful AIs cheaper, faster, and just more accessible for everyone doing research. So, what does all this really mean for the future? Well, by changing the problem from one of memory to one of perception, Glyph has basically opened up a completely new road for scaling up AI. The researchers are suggesting that this visual approach could be the key to finally smashing past that million-token barrier and maybe scaling all the way up to 10 million tokens, or even beyond. We're not just talking about small improvements anymore. This is a potential paradigm shift in how we get computers to handle massive amounts of information. So why should you care about this? Well, imagine AI agents that can actually remember your entire conversation history, not just the last 5 minutes. Or an AI that can instantly scan a company's entire legal history to find one specific case. Or think about a project manager AI that has perfect memory of every single decision made on a project over years. That's the kind of future that a technology like Glyph starts to unlock. So if you remember just one thing from all this, let it be this term: visual text compression. That's the simple but really powerful idea at the core of Glyph. Instead of feeding an AI a long, inefficient string of words, you just show it a picture of those words. It's a completely new way for AI to read. Look, this technology is really just getting started, but the potential is absolutely enormous. So I'll leave you with this question to think about. If you had an AI that could instantly read and understand any document, no matter how long, what's the first big, complicated problem you would set it to solve?